We ended the last video with the remainder theorem, which basically said if I had a polynomial, that if I divide it by x minus some number c, the remainder will be f of c. The factor theorem is essentially a special case in which x minus c actually divides evenly into the polynomial, which means that the remainder would be 0. Okay. So if I have a polynomial and c is some number, if f of c is 0, so if c is a 0 of the polynomial, when I plug it in I get 0, what that tells me is that x minus c is a factor of the polynomial. Okay. And the second part says if x minus c is a factor, then f of c is equal to 0. Okay. Now we've certainly seen this second part before, that when I write a polynomial in factored form, and set it equal to 0, I can set each factor equal to 0 to get my solutions. And if x minus c is 0, x would be c. So that does give me, a factor always gives me a 0. This theorem says it works the other way too. If I have a 0, I know there's a corresponding factor. So they always go together. If I have a 0, x minus that 0 is a factor. If I have a factor of the form x minus some number, that number is going to make the polynomial 0. So that's a very powerful result. I'm going to use that for a problem. Given the wonders of video editing, my problem has mysteriously appeared on the board. F of x is x cubed plus 2x squared minus x minus 2. Now we're given that x equals 1 is a 0 of this function. And we're being asked to use that given information to find all of the zeros and then to factor completely. And of course, these questions are greatly related because zeros correspond to factors and vice versa. That's what the factor theorem tells us. Okay, now this problem is a little bit contrived because I'm giving you one of the zeros. Right now, we're just learning how to work with that. In the next chapter, we're going to learn how to make some educated guesses about numbers that are likely to be zeros, and use some trial and error so that we don't have to be given this information. Right now, we're just going to figure out how to use the information once it's given. Okay, so if x equals 1 is a 0, then I know that x minus 1 is a factor. Now what that means is that f of x can be written as a product of x minus 1 times something. I'd kind of like to know what that something is. But I can find it because that's just going to be f of x divided by x minus 1. If I wanted to solve for what's here, I'd divide the x minus 1 over to the other side. But I know how to do that. In fact, I can use synthetic division. So we've got 1x cubed, 2x squared, negative 1 copies of x, negative 2. Quick check, constant, x squared, yes, x cubed. The number that goes out here is the 0. Given the 0, that's what I put out here. Given the corresponding factor, which is x minus the 0, I change the sign to get the number to put out here. So do be very careful with that. All right, so I copy this 1, and now we multiply and add. 1 times 1 is 1, plus 2 is 3. Times 1 is 3, minus 1 is 2, times 1 is 2, plus negative 2 is 0. Excellent. Now, I knew I should get 0 here because I was told that x equals 1 is a 0. So I knew my remainder should be 0 because that's going to equal f of 1. And I knew that x minus 1 was a factor, so it had to divide in evenly. What this does is that it gives me the other factor. That's going to be x squared plus 3x plus 2. Okay. Now, what's nice about that is that one is quadratic. Once I'm down to a quadratic, I can factor it without having to know these zeros. If it factors nicely, I'm just going to factor it. If I struggle with factoring it, or if it doesn't factor nicely, I can use the quadratic formula to get zeros, and then zeros correspond to factors. This one, I think we're going to actually be able to just unfoil. If I view that as the result of foiling, in order to get x squared, I'd have to have x and x. The only integers that are going to multiply to give me 2 are 1 and 2. Same sign, looks like both positive. Let's see if this works. I think so. Outsides are 2x, insides are x. That gives me 3x. And the last terms give me the plus 2. So we end up with, we've now got it factored completely. We've answered part B first, x minus 1 times x plus 1 times x plus 2. Fabulous. And then what are all of the zeros? The answer to part A would be 1, the 0 that we were given. And then what number would make that 0? Negative 1. And what number would make that 0? Negative 2. So we found all of our zeros, and we found all of our factors. Okay, now I'm going to give you one to try. Same directions. I'm going to give you a polynomial, and I'm going to give you a 0. It's not going to be 1 this time, though. I'm going to change the polynomial and change the 0. So we're going to let f of x equal 2x cubed minus 4x squared minus 11x plus 15. And I'm going to give you that x equals 3 is a 0. Same directions. I want you to then find all of the zeros and factor things completely. Now, I'm going to caution you, after you do your synthetic division, you'll have the product of a linear and a quadratic. That quadratic isn't going to factor as easily as this one did. You may need to use the quadratic formula. See if you can figure out how to go about doing that, and we'll go over that together in the next video.